Okay, we are doing a first principles question next. So this is very, very similar to question number 9 from 2018 paper 2. And it says we're showing that sine differentiates to cos. Okay, so you'll get this, or cos to sine, or minus sine to minus cos, or something like that. These results over here, they come from small angle approximations, but you are allowed to just use them once you have sort of reliably led up to those points. Okay, so first principles, when it's first principles, it means that we need to use the idea of, well, it's in your formula booklet. It's sort of given by this. Okay, so we're going to start by writing that one there, and then we're going to substitute in. The top line is all about sort of the y part, the functions parts themselves, okay? And the bottom part is about the x parts, or the difference between them. That's why I've just jumped to h. So your functions themselves are sort of going in here. So x plus h, what does it mean? It means you take your function and you change all of the x's, or thetas, or whatever they are, to x plus h. So it means on the top one, we're going to write the limit of h goes to 0. We're not going to write this 20 times, by the way. We're just writing it a few times throughout. Of sine of, well, I suppose theta in this case, theta plus h minus. So this is the same thing now as before, but just without the h on the input bit. So it's like that, okay? So we're going to do that. What are we going to do next? We are going to use the addition rule. If we don't use the addition rule, well, we can't really do anything. So we are going to say, so sine theta, let's use some colors just to make it nice and clear. So sine of one, cos of the other, plus cos of the first, sine of the other. And then this is just the same bit from before, minus sine theta over h. And we want to use, I said I wasn't going to write the limits 100 times, but I'm tempted to because of how they're written there. So we're then going to use this as a guide. So sine h, 1 minus cos h. Okay, so let's do our next step. So what I'm going to do is I'm going to write these into two fractions. I'm going to write them as fractions that have sine theta in them, and I'm going to write them, I'm going to write this on its own as a fraction that only has cos theta in. So let's do that now. So we're going to say sine theta cos h, and then I'm going to jump to minus sine theta. And we're going to put that in its own fraction now, I think. H as the limit of h goes to 0. I'm going to write that one, and then I'm going to write another fraction, which is going to be plus 1 for the cos. So cos theta sine h over h. Now, in the interest of a little bit of time, I'm going to... Where is it? I'm going to do this for one of them, and I'll encourage you to look back now at the results. So if you imagine I'm just doing cos theta, and then I'm thinking of this as its own part, can you see that we're getting very, very close to this? In fact, if I just moved that one out of the way, if I just change the order, and there we go, and went like that, that is in fact what? Well, 1, isn't it? Okay, so that's how I'm using that result. And from this bit here, I'm going to get cos theta. Now, how about this one then? Well, on this one, it needs a bit more work first, I think, doesn't it? So what we need to do is we need to have a think about where is something like this coming from? Well, if I factorize out sine, yeah, so if I factorize out sine, it would leave me with cos h minus 1. And let's do the same thing that we did just a second ago. let's put the sign over here. And then when I say over h, well, it is the same as just doing over h for that. And then I can copy the limit down. Now, this has got the result the other way round to how it normally is, okay? But it is also true that cos h minus 1 over h leads to 0. In fact, it's really easy to kind of just force it to happen, if you like. I could just factorize a minus there, yeah? And there you go. Now it's the same, isn't it, as this result up here. Okay, so you can brute force it into being 0 if you want to, but that's not normally something you would need to think about. The point is that this whole bit here is going towards 0. So 0 times sine will disappear, and you will be left just with your cos bit. Okay, so I made a little bit of a jump there just because it gave it to us in a slightly unusual way here. But the general steps are as follows. So you write your formula, you substitute in the actual function that you've got. For this one, we want to use the addition rule. Okay. After we use the addition rule, we want to make 2 fractions. Okay. And then after we have those 2 fractions, we need to kind of like make it match the results. So make it match the results as in the question, which you do not need to prove, okay? And then you needed to eventually show that it only goes to cos theta. You could put, if you felt a little bit apprehensive about this, you could put some intermediate lines in. So you could say, 0 times sine theta, isn't it? Plus 1 cos theta, okay? To get to that as well. But I hope that kind of shows you how you would go about doing it. So first principles with sine and cos is very much going through these steps.